Welcome back to our podcast, Tasting Terroir, a journey that explores the link between healthy soil and the flavor and health of your food. I'm your host, Sarah Harper. This week, we are going to do something a little different. We're going to dive into a topic that has a lot of connection to the health and flavor of your food and is something that most consumers, at least, I don't think know a whole lot about. This secret that is making your food taste better and bringing more nutrients into it is actually a fungus. Mycorrhizal fungi, to be more precise, is an amazing, amazing story. And so we're going to dive into it a little bit with some expertise from Dr. Jill Clapperton, of course, and we're going to recommend some resources for you, some great books that will help you understand not only this amazing fungus, but a whole lot about the world underneath our feet that are making up the different flavors and health aspects of our food. According to the University of Wisconsin-Madison, the word mycorrhiza means fungal root. To be more specific, mycorrhiza are fungi that have a symbolic relationship with roots and many plants. The fungi, which commonly form mycorrhizal relationships with plants, are ubiquitous in the soil. Many mycorrhizal fungi are obligately symbiotic and therefore are unable to survive in nature for extended periods of time without their host. Because the relationship between the fungus and the plant is symbiotic, both members of the relationship obtain a benefit from each other. Neither the host plant nor the fungus suffer any ill effects as a result of the relationship. The fungus, because it does not photosynthesize, cannot fix its own carbon. Consequently, it receives all of the necessary carbohydrates from the host plant through its roots. In return, the mycorrhiza absorbs nutrients from the soil, which the plant can't break down by itself, and passes it along to the plant through the root. In most situations, roots of a plant occupy 0.5% of the topsoil volume and even less of subsoil. Because the hyphae of mycorrhizal fungus are thinner than plant roots, it is able to come in contact with more soil on a per volume basis. The mycorrhizal fungi are made up of root-like structures that possess a network of mycelium external to the roots of trees and plants that extend into the soil. This mycelium absorbs nutrients and translocates them back to the host plant. As a result, there is an increase in the absorption surface area of the roots. This amazing fungus helps break down minerals in the soil and turn them into usable pieces of food for plants. It does this by literally entangling itself into the plant's root. It lives inside the plant root. And it's been doing this almost since the very first discovery of plants and fossils. It's an amazing story about how connected the world underground is and the impact of that on us. To get a better understanding of the science of all of this, let's next listen to Dr. Jill Clapperton as she explains more about mycorrhizal fungi and how it works to build health in the soil.
Mycorrhizal fungi hold it all together. They leak glomalin, which is a glue which binds soil particles together. They cast a net, right? Which so the net totally starts building bigger structure, getting bigger things together. So now we start to have better soil structure. And what else do we get? We have water stable aggregates now because the soils now are that glomalin is not a water soluble thing. So now we're actually gluing them and making them water resistant. And that's the important part of this. This is mycorrhizal fungi sort of more up close and in person. And you can see they have quite robust hyphae. This is the colonization point. So this is the point where the mycorrhiza are actually going into the cell and forming these tree structures, or, what they look to me like clumps of grapes and grape stems. And they're actually meshed with the cell membrane. And this is where all the trading happens. So this is where your mycorrhizal fungi trade the plant for amino acids, organic acids, and carbohydrates and lipids. And so they're taking that from the plant. And then the plant is getting in return water. It is getting mineral nutrients. It's getting mostly mineral nutrients, but it's also getting a secondary benefit because the mycorrhiza actually really rely on the plant because they can't survive without a host. So what they do is they create this mycorrhizosphere that is conducive to plant beneficial microorganisms. So these are plant growth promoting rhizobacteria. And they make this environment because the mycorrhiza are preferentially asking the plant to produce amino acids, organic acids, and then carbohydrates. So the composition of the photosynthate is different in a plant that's colonized by mycorrhiza. And so then it's leaking different compounds, which are very much conducive to the plant having a beneficial rhizosphere. And again, the mycorrhizal fungi are selfish. They want the plant to survive. Without the plant, there's no way to feed the organisms except on organic matter. So they're all up at the top. They're all your detritivores. You need the soil to have that structure so that everything can have a habitat because your soil is your habitat. So you not disturbing the soil, we're creating a continuous soil pore network. So we have this beautiful habitat. So now the organisms and the plants are going to modify that habitat even more to their liking. So we're going to have rhizodeposition. So this is root exudates coming out of the plant root. We're going to have organisms like mycorrhiza and rhizobium going into the root, but they can send out signals that actually attract more in there. And nutrients can go both ways. Mycorrhizae can actually leak things out of their hyphae in order to attract more things. So they just extend the root system. Growth promoting substances. Yeah, I mean, there's going to be a lot of bacteria and fungi that are going to exude growth promoting substances. And they're going to be doing that because they want more roots. And they want more roots, right? They want roots to grow fast. They want more roots because they want more habitat on the roots. They want more root exudates. So they want more roots. So they're going for roots. Your pathogens are exuding growth inhibiting substances because they are lousy competitors. They can't jump on a fast growing root, not at all. So they're going, hey, you got to slow down. We need you to slow down because we can't get on. So they're sending signals to slow down. The growth promoting ones are trying to outweigh the ones that are trying to slow down. And all this is going in and around the roots. So the root is dealing with all of this all the time. And we don't want it to deal with some of the more negative things. We want it all to be positive. So when plants are colonized by mycorrhiza, look what happens. We got bacteria, we got fungi, we've got protozoa, and we're creating this beautiful habitat in and around the roots. So now the roots have all this recycling going on, and so they can use all these nutrients. We have better soil structure because we have all the fungi holding together all the aggregates. And so we have better water holding capacity too, right next to the root. So which, if we don't have a mycorrhizosphere, we're not going to hold nearly as much water. We're not going to have nearly as much disease control because we haven't got a buffer here. We haven't got something fighting for us. We need something fighting for us. And that's part of what your saprophytic fungi do too, is they create this network, just not immediately right next to the root or attached to the root, but they're creating a better soil structure. And that's always what we want. So mixed species, you can see, here we go. We have everything in the same space. But if we mix them up, so that could be using companion crops, using mixed plantings, not even just not planting the same grass, planting mixed grasses. We want to fill the profile with roots and different kinds of roots and different kinds of root exudates, because every different plant you put in the ground exudes its own signature of plant compounds. And those compounds are designed to create this microbial mycorrhizosphere, plant biological community around the roots that protects the roots from being overgrazed, from being parasitized. It's all about making sure the plant continues to grow and is healthy.
Jill did a great job of explaining the science of mycorrhizal fungi and the relationship they have to really creating soil health and healthy food. And I was thinking about how do farmers really work with that and think about that. And I came back to a clip from an interview I did with farmer Gail Fuller in Kansas. And I really valued his perspective on this whole network and how it works and what is his role in dealing with it.
As we learn more and more on the scientific side of all of these things connecting and communicating, and not just plant to plant, but plant to animal and plant to insect and fungi to insect and fungi to root and all these, that's like me talking to a tiger.
Yeah.
who says all of this stuff isn't talking to me? I'm too arrogant to listen. And so that's kind of where I am right now, is I'm trying to become a part of that ecosystem, and I'm trying to do more time sitting and listening to my farm than I am talking to or talking at my farm or managing. I'm trying to let it talk to me, and I'm trying to learn how to listen. Mm-hmm. And I don't know that language very well, but I certainly know it a heck of a lot better than I did 20 years ago. And I think, I've always been one to kind of get on farmers for not carrying the spade with them. And, what's your soil look like? Because most don't even know. But I'm kind of getting to the point now in my journey that I can look at my soil without a spade and tell you if it's healthy or not. How many insects are crawling or flying above this particular patch? How many birds are sitting there? How many, whatever. If you're void of life above ground, you're probably void of life below ground.
Another helpful resource in understanding the mycorrhizal network and the role that it plays in our food is the book Teeming with Microbes, The Organic Gardener's Guide to the Soil Food Web by Jeff Lowenfels and Wayne Lewis. And in chapter 1 of their book, they explain mycorrhizal fungi and I think give a helpful image, the root exudates that we're talking about that are the chemicals put out by the roots that then feed the mycorrhizal fungi and other bacteria and fungi and build this web that is this amazing source of life in the rhizosphere. The analogy that they give to help understand root exudates is a human root exudate of sweat. So sweat is our exudate. We're putting it out through our bodies. And that just can help you maybe get a visual of what's going on there. That roots are actually putting out chemicals into the soil that are designed to feed fungi that then will bring them food. This great symbiotic exchange that happens underground and helps them to bring in nutrients and trace minerals that they can't get themselves. I mean, remember, the plant can't move. It is stuck in one place. And so to get the nutrition that it needs, yes, it sends out roots to forage where they can. But really, what if it's planted in a place that just doesn't have all that it needs? Well, this mycorrhizal fungi network starts to explain how this nutrition from afar can be pulled into the plant through this exchange. As the Teeming with Microbes book notes, this also helps us to understand why things like synthetic chemical fertilizers and pesticides, insecticides, fungicides, and tilling up the soil to plant a new crop, why all of those disruptions can negatively impact the ultimate health and flavor of our food. In their book, they note that, quote, chemical fertilizers, pesticides, insecticides, fungicides, and then they later talk about tillage as well, affect the soil food web. Toxic to some members, warding off others, changing the environment. Important fungal and bacterial relationships don't form when a plant can get free nutrients. Now, I think that's a really important concept to just take in, because when you're applying a fertilizer to the plant, it's not coming from the soil. It's not being broken down by the mycorrhizal network. It's just being put there. The analogy that I've heard used sometimes is giving the toddler a choice of a cupcake or carrots. Well, they're probably going to pick the cupcake. So it's a free, quote unquote, giant burst of energy that you're giving the plant. But because it didn't have to work for it, it didn't have to do that exchange that's important in the soil. Well, then it didn't put out the exudates, and it didn't build the mycorrhizal fungi network, and it didn't do all of the things to the same level that it would have to do if it didn't have that artificial boost of energy just given to it. So returning to the book, when chemically fed, plants bypass the microbial-assisted method of obtaining nutrients, and microbial populations adjust accordingly. The trouble is that you then have to keep adding chemical fertilizers and using the asides because the right mix and diversity, the very foundation of the soil food web, has been altered. And that's another important point, I think, for us to ponder as we are either working in our own gardens or trying to buy food that is healthier for us and our family and claiming to be regenerative. Disruption, whether it's from chemicals or from tillage, is disrupting the variability that naturally is there to bring nutrients into our food. And so when we're buying food that's coming from a very disrupted system, either a system that heavily depends on chemical fertilizers and pesticides or a system that heavily depends on tillage, either of those systems are going to create a less optimal outcome. I mean, they just have to, because the whole way of bringing nutrition into a plant has been disrupted. And to the point on tillage, it's not just chemicals that are disrupting the system. The book notes, if the salt-based chemical fertilizers don't kill portions of the soil food web, rototilling will. This gardening rite of passage, and I would also add organic food production rite of passage, it happens a lot in organic production to control weeds, breaks up the fungal hyphae, decimates worms, rips and crushes arthropods. It destroys the soil structure and eventually saps soil of necessary air. Again, this means more work for you in the end. So what it's talking about there is, remember, we've got this network of fungi and bacteria and soil particles all trapped together. And it's this whole amazing zone of life called the rhizosphere all around the roots. And whether it's through a chemical that reduces the biological activity or physically churning up the whole environment that was built, either of those disruptions is going to cause some real shortfalls in the outcomes that we could have. But it's important to note that any kind of commercial growing is going to require some disruption. I mean, we're not hunters and gatherers for a reason. We want a stable, large supply of food. We need that. And to do that, we have to alter the natural system in some way. There has to be some kind of disruption. But the key thing that I think gets missed in all of this discussion about, is it organic? Is it regenerative? What is regenerative? Is that the people who are doing regenerative farming, that are farming with nature, that are being, as we talked about in the last episode, these constant, curious companions of nature rather than trying to tame her. What's happening there is that they are becoming really good at restoring the disruption, at minimizing it in the first place, not needing as much of it, and then taking measures and practices that help nature to repair itself more quickly after this disruption, whether that disruption is physical from tillage or chemical from synthetic or even natural fertilizers that would be applied. And so we can start to understand that what regenerative means and what it is in practicality is really about that. It's creating the least intrusive disturbance possible and then helping nature to recover from it so that you can still get as much of the benefits of a natural nutrition system as possible. So we can see now the link between these kind of artificial disruptions that happen in conventional or organic agriculture and health of food, with nutrients disrupted from getting in through the root of the plant, as we've talked about, through those mycorrhizal fungi networks. But what about flavor? I mean, is that really affected too? And of course, it would seem to be. It makes sense because the nutrients, particularly the trace minerals that are coming into the plant through the mycorrhizal network, are going to affect flavor. But how do we know? To get some insight on that question, let's go back to an interview that Jill Clapperton and I did with David R. Montgomery and Ann Bickley about their book, What Your Food Ate: How to Heal Our Land and Reclaim Our Health. I love that you did spend so much time on that link between flavor and health, because that is what we're trying to get at. But so often when we talk to people, they'll be like, well, I think so, but I don't know. Well, we don't know. And I'm like, they found a lot of science behind, which intuitively makes sense. It makes sense that when you taste a really good tomato, that it's because it has more nutrients in it.
You know, I think Anne was the one who first sort of between us started digging up papers that looked at, how there's taste receptors throughout the organs of the human body that tie into what when we taste them in our mouths, we call flavors, but that they're really sort of sensory receptors to what's in our food. And when you think evolutionarily about, think in the days of before food processing, say when we were mostly hunting and gathering, it would make sense that the foods that our bodies needed would be foods that tasted good, that there'd be a positive feedback, that people that ate healthy food were healthier and had more progeny and then were better represented in future generations. It just makes very simple evolutionary sense. All the way through to the point when we really started to do like massive food processing and changing things, taking whole foods, breaking them into their components, and then remixing them in ways that broke the link between flavor and what's actually in food. And that makes it, I think, very challenging for us today to really kind of appreciate that and understand it. But we've all had the experience of eating those flavorless tomatoes that you can occasionally buy at the grocery store, or having that absolutely delicious heirloom tomato that somebody you knew grew in their yard that kind of melts in your mouth and you go like, my God, this is what tomatoes supposed to taste like. And that applies to all kinds of foods in terms of fresh whole foods. There hasn't been a huge evidentiary basis. And one of the things I think we were a bit surprised by is that there's not a lot of studies that make that connection. The ones that do are pretty clear. But there's a lot of, back to your question of sort of what are the gaps and what's needed. I mean, there's more interest, I think, in the terroir beyond wine is how I like to think about it. That food has a terroir and that it relates to flavor. And, and terroir is a big complicated concept that integrates everything from the atmosphere to the soils, to the weather, to the microbes and the life in the soil. But, it may be that all of that actually really does impact what gets in our food, and how we farm impacts, all that at one scale or another.
Absolutely. I mean, I think back to this, Anne, that's how you and I met.
Yeah.
In person. On that panel that was mediated by Dan Barber.
Oh, right.
And
absolutely.
And we were talking about taste, and can you measure taste, and can you, and if something tastes good, is it really good for you? Because intuitively we believe that. I mean, and to your point, that gap, that is a serious gap in the literature, because linking that idea of taste, because taste and aroma and these things are all more like a social science, because they're so subjective, like whether you have those inadequate sensory organs, or whether you don't, how you taste flavor. And then not all of us need the same things, as you pointed out earlier, right? Like, and at certain stages in our life, or certain stages of the day, or whatever our stages of health are, we need different things. And so we might, just as a pregnant woman might want fermented foods because of them, maybe it's because of the microbiology. We don't know right now. I mean, that's the whole point, is that we don't really understand that. I know in the lab right now, I've been playing with volatiles and using headspace analysis to actually look at, well, what do we smell? But the thing that is most interesting to me is that all of those things, I can buy them separately. Like when I started to look at that, I thought, oh, that's amazing. Look at that aldehyde. Look at this. Look at this. And then I realized that they were all for sale. And you can add them all in. How you want. And I was flabbergasted. I really was. I was like, There's nothing new here, Jill.
Well, so is what you're saying, Jill. So then if you can buy all of these volatiles, like somewhere in the food industry, is that what you mean?
Yeah.
Then why grow them? Well, here's why. Here's why, girl. Because there's no, as good as any food industry chemist might be, I don't believe that they truly understand the proportions and the particular, variant of a phytochemical that goes into the flavor profile that the human body goes, oh yeah, that I'm hankering for more of that. Food industry, great. They'll just shove sugar and salt into something and the human being will eat it. And that's a totally, that's tapping totally different kinds of levers. And I thought that's what you meant, Jill. And it reminded me of something that is kind of, happening right now around. So the millennials and the Gen Zers are sort of down on alcohol these days. And so there's, dry October, dry January. And we are in the modern era, though, and you need to drink something, right?
Yes.
So instead of just drinking water, the food industry, whomp, are they ever onto this? Aha. Mocktails,
Yes.
beer and wine with no alcohol. Okay, fine. Or if you want to drink soda pop, you can drink that. And then, so I was thinking about this, and I was over the summer, I was sitting having dinner somewhere. This happened to be in Maine, and the only place they had a seat was at the bar. And I'm like, okay, yeah, I'll sit at the bar. So of course, what do I start doing? Oh, here, can I sit? Let me take a look at that label on your bitters thing. And oh, what's in that gin? And it's all sitting there. And it's like, I'm kind of bored. I'm like, oh, just reading the labels on all this stuff. And what was really interesting to me on the orange little container called Orange Bitters, I'm expecting to see
Orange.
Exactly. There was not one genuine citrus derived ingredient in that stuff. It was phenyloxyl this, benzyl that. The whole thing was a big chemical cocktail, which, okay, maybe some of those volatiles truly came out of a citrus, but not in the proportion and combination and so forth that you'd actually find it. So in other words, this is all, they're just kind of hijacking and jerking around our body wisdom with all of these flavorings that are going into all of these non-alcoholic things, which I would like the Gen Zers and millennials to know. I mean, why can't we make wine instead of 15% alcohol content? Great, let's get it down to 11 or 12%. Why do you think the French for so long have been able to, drink a bottle of wine at lunch? Well, because it's not 15% alcohol that leaves you on your face.
But there's that abundance, isn't it? More.
Oh,
more. If I can have this little bit, why not have more? I can create something that's more. I mean,
yeah.
I mean, and you put that in, you talk about that in your book about more. And I certainly see it, but I think the point that we talked about earlier about the whole is really important, because we don't understand, and you made this point too, we don't understand what all these phytochemicals do. Do they help us take up other nutrients? What are the helper molecules?
Yeah.
Like when we eat whole foods, where are the helpers? Well, we don't even know what the helpers are, but I think back to mycorrhizal fungi, and there are helper bacteria that, you can't actually have colonization unless I have this microbial community around the root in order to help stimulate that change. And I think that our guts and a lot of other things work that way. We need whole foods. We need whole plant extracts. We need this wholeness in order to get all the nutrients we need, because otherwise, if we're just cobbling them all together in what we think is good for us, is it?
Yeah.
Yeah, we're sort of missing the potential ubiquity of synergistic effects, where it's not so much the individual elements, but the combinations that we take them up in that matter.
Regenerative agriculture is when you farm in ways that bring life back to the soil, if it's kind of short on life in the first place, or if you got pretty decent soil, your practices are just continually improving and replenishing that, so that biology is functioning normally, which is to say exactly how it's supposed to be functioning between the fungi, the bacteria, the metabolites, and everything.
So we're starting to see how the link between soil health really can exist to the flavor and health of our food. Aha! The podcast premise is proved. And I think understanding what's going on with mycorrhizal fungi and how the symbiotic relationship is really creating this pathway toward nutrition and flavor, giving us that understanding of how this happens also really helps us understand how it can be disrupted. And then, of course, what to look for as we buy regenerative food or as we get started this spring in the garden ourselves. Another book that I would really recommend to get a deeper and rich understanding of not just mycorrhizal fungi, but the whole amazing world of fungi is a book called Entangled Life by Merlin Sheldrake. And the subtitle of the book is How Fungi Make Our Worlds, Change Our Minds, and Shape Our Futures. And it is truly just a fascinating tale of the impact that fungi have and that we're often so unaware of because it's out of sight, out of mind. In chapter 5 of his book, entitled Before Roots, he also talks about this issue of flavor and the connection that mycorrhizal fungi in particular has to affecting flavor. And so I just wanted to share a little passage with you and encourage you to get the book and read the whole thing. Quote, a plant's fungal partners can have a noticeable impact on its growth and its flesh. A number of years ago at a conference on mycorrhizal relationships, I met a researcher who had been growing strawberry plants with different communities of mycorrhizal fungus. The experiment was simple. If the same species of strawberry was grown with different species of fungus, would the flavor of the strawberries change? He conducted blind taste tests and found that different fungal communities did seem to change the flavor of the fruit. Some had more flavor, some were juicier, some were sweeter. Strawberries aren't alone in being sensitive to the identity of their fungal partners. Most plants, from a potted snapdragon to a giant sequoia, will develop differently when grown with different communities of mycorrhizal fungus. Basil plants, for example, produce different profiles of the aromatic oils that make up their flavor when grown with different mycorrhizal strains. Some fungi have been found to make tomatoes sweeter than others. Some change the essential oil profile of fennel, coriander, and mint. Some increase the concentration of iron and carotenoids in lettuce leaves, the antioxidant activity in artichoke heads, or the concentrations of medical compounds of St. John's wort and echinacea. So again, we are seeing evidence of what makes common sense, that the natural way of bringing nutrients into plants would affect the flavor, and that when we disrupt that too much, especially, we lose more than we would like. We lose both health and flavor. But the good news, the flip side, is that we can also restore it. We can restore it in the way we grow our own food and in the way we buy food, in the type of food that we support. And just want to remind you that we are featuring folks that are in our network that are growing food in this better regenerative way, this least disruptive, most naturally assisted way that's being called regenerative. You can find that by going to our website, globalfoodfarm.com/betterfood. And while I'm on the subject of our community, I do want to take just a few seconds here to encourage you to think about joining us. And you might wonder why. Why, when there's so much free content, when we provide a lot of free content. A couple of things. One, there's so much more that we provide inside of our private community. It's at a depth that we just can't produce for free, and we don't. Interviews with farmers from around the world who are truly making amazing strides in the improvement of soil health, so that other farmers can learn directly from them and apply those same methods themselves. We also feature discussions with food companies that are on the regenerative journey and what it is that they're looking for and how they're defining it. And we facilitate that cross-dialogue across the supply chain that's usually missing. And if for no other reason, and really, this is reason enough, every week, except for when she's traveling, every week almost, you get the opportunity to ask Dr. Jill Clapperton any question you have about what's going on in your garden or your crop, which cover crop species that she might recommend for a given problem that you're facing, or just any soil health question you might have. The chance to ask this top soil health nutrient density testing researcher any question that's related to your farm or your garden is worth the price that we're charging alone. And it also helps us to continue doing things like this, to educate consumers, to put forth information about regenerative agriculture that's hopefully more fact-based, less flashy, and building a consumer base that can really appreciate and support and reward the kind of work that farmers like you perhaps are doing. So I really would encourage you to think about joining us at globalfoodfarm.com. You can click the link to become a member and see if that is something you want to try out. Each membership does start with a free 3-day trial, so you can see the kind of content that we have, the kind of network that we are facilitating, and decide if you think it's worth joining. If you're a consumer or a home gardener, I would encourage you to join as well. Even though sometimes the soil health discussions in some of the segments of the community might be a little intense, there's always somebody there that's excited about translating that to your level and to a gardenscape instead of maybe a farmscape scale. And you can learn a lot from these people. Again, it's a global community featuring farmers from around the world, all doing these different regenerative practices. And so it's a private Facebook style group, but with lots of different original content, our own digital streaming library, and no advertising, no tracking, and no selling to you, and no negativity because we don't allow that. And we feel it's very important to keep focusing on the positive and on continuous improvement and not on just tearing down the ideas or progress of others. So I think those things make it a unique learning environment that really help facilitate going further faster. Well, today we have looked at this really fascinating symbiotic relationship between fungus and plants. And as I wrap it up, I just want to take a moment to note that I think there's an opportunity for us to apply that to ourselves too. We can become somewhat like the mycorrhizal fungi in how we purchase and how we learn and in what we do with that learning. If we go out and forage and break down information and then bring it into the roots of our friends and family, of our network, our social network, then we are becoming something like, loose analogy, this amazing natural network that does the same thing underground. And it just puts an emphasis on how important it is not only to break down and learn and absorb information ourselves, but then to take that information into our communities and our networks and our relationships and to share it with people that don't know as much about it, but certainly need to, because we all eat every day. And wouldn't it be great if we could eat even better, both in terms of health and flavor? So I would really encourage you to share the information that you're learning, share what you're doing in your backyard, share this podcast, share other podcasts like it that are focusing on health and flavor and food, and be part of a network that is bringing more life back into our food and encouraging people to buy from the people who are doing that. You've been listening to Tasting Terroir, a podcast made possible by a magical collaboration between the following companies and supporters, all working together to help farmers, chefs, food companies, and consumers to build healthier soil for a healthier world. Rhizoterra. Owned by Dr. Jill Clapperton, Rhizoterra is an international food security consulting company providing expert guidance for creating healthy soils that yield tasty, nutrient-dense foods. Check us out at rhizoterra.com. That's rhizoterra.com. And the Global Food and Farm online community, an ad-free global social network and soil health streaming service that provides information and connections that help you apply the science and practice of improving soil health. Join us at globalfoodandfarm.com. And from listeners like you who support us through our Patreon account at patreon.com/tastingterroir. Patrons receive access to our full-length interviews and selected additional materials. Patrons will also have the opportunity to submit questions that we will answer on the podcast. Tune in next week to hear more interviews and insights with myself, Sarah Harper, and Dr. Jill Clapperton, as well as the regenerative farmers, chefs, and emerging food companies in the global food and farm online community and beyond. If you like our work, please give us a 5-star rating and share the podcast with your friends. Thanks so much for listening and for helping us get the word out about this new resource to taste the health of your food. Until next week, stay curious, keep improving, and don't stop believing that better is possible when knowledge is available.